Welcome back to the deep dive. Today we're zeroing in on Anthropic's big new release, Claude Sonnet 4.5.
Yeah, and they're not being shy about it, calling it the best coding model in the world. That's quite a statement.
It really is. So, our mission today for you listening is to cut through the hype. We'll focus strictly on the architecture, the performance, what this means for building software for enterprise AI.
Exactly. We're going deep into the technical details, the API changes, especially around memory and context. We want to understand what these performance claims actually mean in practice.
Right. We've been digging through their docs, looking at benchmarks, some early developer feedback. So let's start with that headline claim, best coding model. What numbers are they actually using to back that up?
Okay, so they're really highlighting performance on some key benchmarks that try to mimic, real-world coding challenges. The big number is 77.2%.
Okay, 77.2% on what exactly?
That's the success rate they hit on the SWE-Bench Verified benchmark.
Ah, SW-Bench. And just to remind everyone, that's not a toy problem set, right? It's based on actual kind of messy GitHub issues and pull requests.
Exactly. It's designed to test how well a model can fix real bugs and implement features found in the wild. So 77.2% is a strong number there.
And I saw something about parallel compute boosting that even higher.
Yeah, they mentioned hitting 82% if you allow for parallel test time compute. It shows a pretty significant capability for reliable code generation and modification.
And how does this stack up against their previous top model, Opus 4.1?
Well, that's interesting. This 77% figure suggests Sonnet 4.5 is seriously competitive, and they even say it reportedly starts to outperform Opus 4.1 in certain specific domains.
Like what?
They mention financial services problems, for instance, which suggests some specialized tuning, perhaps.
Okay, so strong on coding tasks.
Yeah.
But you mentioned another benchmark, something about general computer use.
Yes, and this one I think is maybe even more telling about the architectural leap. It's the OS World benchmark.
OS World, what does that measure?
It tests the model's ability to perform complex tasks using a computer environment, things beyond just writing code, like navigating file systems, using command line tools, understanding system interactions.
The number there?
Get this, 61.4% success rate.
Wow. Okay. How does that compare?
It's a huge jump. The previous Sonnet 4 was around 43.9%, I believe. And even the high-end Opus 4.1 was only slightly better, around 44%.
So nearly a 20 percentage point increase. That's massive for system-level tasks. How did they manage that kind of improvement architecturally?
Anthropic points to a few key areas. Enhanced planning and system design capabilities seem crucial. It's not just about writing code anymore, but about sort of architecting the solution first.
Makes sense for complex tasks. What else?
They also mentioned better security engineering, finding vulnerabilities, that sort of thing, and just more precise instruction following, especially for multi-step procedures.
So better planning, better security awareness, follows instructions better. It sounds like they're making it more reliable, less likely to go off the rails.
That definitely seems to be the goal. One interesting technical note they included is about optimization.
Oh.
Apparently, Sonnet 4.5 gets significantly better results on the really complex coding problems if you enable something called extended thinking.
Extended thinking. Sounds like it takes longer.
Exactly. It likely involves more internal computation or reflection steps. The trade-off, as they point out, is that it impacts prompt caching efficiency.
Ah, the classic speed versus quality trade-off. Developers need to be aware of that setting then.
For sure. More complex reasoning might cost you a bit on the back-end efficiency.
Okay, so the benchmarks are impressive, especially that Osworld leap. But performing well on a benchmark is one thing. Sustaining that performance over time for complex, long-running tasks, that's the real challenge for AI agents, isn't it?
Absolutely. And this is where Anthropic makes another pretty astonishing claim. They're talking about the agentic leap.
Meaning?
They claim Sonnet 4.5 can operate autonomously for up to 30 hours.
Wait, did you say 30 hours?
30 hours, yeah.
How? I mean, context windows are huge now, but 30 hours, that's like a full work week condensed. How do they manage context drift and maintain state over that kind of duration? Is it just a giant context window?
It doesn't seem to be just about the context window size, though having a million tokens helps. They seem to have fundamentally rethought the approach to long-duration tasks.
Okay, how so?
Compared to Opus 4, which had about a 7-hour limit, this 30-hour capability suggests a different strategy. The model apparently focuses on making steady, incremental progress.
Incremental progress.
Yeah, and providing fact-based updates along the way. Instead of trying to do huge, complex things in one go, it breaks tasks down, verifies its steps, and keeps track of what it's accomplished. It's more methodical, less prone to getting lost.
That makes sense. Like disciplined project management built into the AI,
Right.
less likely to hallucinate or forget the goal halfway through.
Precisely. It's engineered for endurance and focus over these very long time horizons.
Okay, but even with that approach, managing the information over 30 hours, you need tooling. Did they announce new API features to support this?
They did. And this is really key for developers looking to build these kinds of long-running agents. The big one is the new memory tool, currently in beta.
Memory tool, what does that do?
Think of it like this. Your main context window, even if it's 1,000,000 tokens, is like the AI's working memory. It's RAM. It fills up quickly with code, documentation, intermediate steps, tool calls.
Right, especially in a complex software project.
The memory tool is like external hard drive storage for the AI. It allows the model to explicitly save information outside the active context window and retrieve it later.
Ah, so persistent state that doesn't vanish when the context window rolls over.
Exactly. You can build up a knowledge base specific to a project, store user preferences, maintain state across multiple sessions. It's designed to give the agent long-term memory. Developers need to use a specific beta header for it right now, which signals it's still evolving.
That's a major architectural piece. What else? They mentioned context awareness and context editing. Are those related?
They are related to managing the active context window more intelligently. Context awareness is basically the model getting better at tracking its own token usage.
So it knows how much space it has left?
Yeah, and how much space each tool call is taking up. This helps it avoid running out of context unexpectedly and having to abandon a task prematurely, which was a big problem for earlier agents.
Okay, that's awareness. What about editing? Sounds more active.
It is. Context editing is an automatic mechanism to sort of prune the context window as it gets full. Think of it like an assistant automatically clearing old notes off the whiteboard, but keeping the most recent action items.
How does that work?
Developers can set triggers. For example, when the input tokens reach 500K, automatically remove the oldest tool calls and the results. But you can also configure it to protect certain information, like always keep the results of the last 2 successful file reads or the initial user request.
So, smart, configurable garbage collection for the context window.
That's a good way to put it. It helps keep the context relevant over long interactions without just blindly chopping off the oldest stuff.
And these tools, memory and editing, presumably help with tool usage overall,
Yes, and they also mentioned Sonnet 4.5 is better at parallel tool usage.
meaning it can do multiple things at once.
Right, like firing off several web searches simultaneously to gather information faster, or reading multiple code files in parallel to build context more quickly. Better coordination between tools.
Okay, this all sounds incredibly powerful on paper. The benchmarks, the 30-hour runtime, the memory tools. But now for the crucial vibe check, what are actual developers saying? How does it feel to use compared to, say, Opus 4.1 or even GPT-4 or the rumored GPT-5 Codex?
Right, the real-world experience. The first thing people notice is speed. It's reportedly about 50% faster than previous Claude versions.
50% faster? That's significant.
Yeah. One reviewer mentioned a complex pull request review that took Sonnet 4.5 only 2 minutes,
Okay,
compared to maybe 10 minutes for GPT-5 Codex on the same task. So a potential 5x speedup in that specific scenario, that's a huge productivity boost if it holds up.
5 times faster is definitely eye-catching. But is it as good? Speed is great, but not if the quality drops, especially for tough problems.
And that's exactly the nuance that's emerging. For reliability and sticking to instructions, Sonnet 4.5 seems excellent. One report mentioned it successfully fixed a bug that Opus 4.1 actually failed on.
So better than Opus in some cases.
Potentially, yes, particularly in reliably executing based on instructions. However, some developers are saying that for the really tricky deep reasoning tasks, the kind of complex production bug hunts,
Yeah.
they feel GPT-5 Codex might still have an edge. And some users found Opus 4.1 was sometimes better for specific, very deep debugging tasks compared to Sonnet 4.5. It's a bit mixed.
So faster, maybe more reliable for standard complex tasks, but perhaps not quite the same depth for those absolute edge case bugs as the absolute top-tier, most expensive models.
That seems to be the early consensus. It highlights a potential gap between acing benchmarks like SWE-Bench, which tests known fixed patterns, and the kind of creative long-chain reasoning needed for novel, complex debugging.
Which raises a strategic point for people adopting this, doesn't it?
Absolutely. It suggests maybe you use Sonnet 4.5 for the bulk of your development, for its speed and reliability and cost effectiveness, but perhaps keep something like GPT-5 Codex in your back pocket for those truly baffling once-in-a-blue-moon issues.
And how much the new context editing really helps mitigate context drift in those super long, complex sessions is still something that needs real-world validation at scale, I guess.
Exactly. The tools are there, but their robustness in extreme scenarios is the key question.
Okay, let's shift to the developer experience itself. Anthropic also updated Claude Code, their coding agent platform. What's new there for devs using Sonnet 4.5?
They focused on making the interaction smoother. A big one is a native Visual Studio Code extension.
Ah, good. What does it do?
It provides inline diffs. So you see the AI's suggested code changes directly within your editor, highlighted, rather than having to constantly switch back and forth between your code and a separate chat window or terminal.
Oh, that's a huge quality of life improvement, much more integrated.
Definitely. They also introduced a feature called checkpoints.
Checkpoints, like in a video game.
Sort of. The idea is if the AI starts going down a path you don't like or making changes that aren't quite right during a long coding session,
Yeah.
you can quickly roll back the code base to a previous checkpoint that the system automatically saved. It avoids that painful process of manually undoing changes or relying solely on Git commits for quick experimental reverts.
That sounds really useful for trying out AI suggestions without fear. Any other workflow improvements?
Yeah, they mentioned better status visibility in the terminal interface, so you have a clear idea of what the agent is doing, and also a searchable prompt history.
Searchable history is always welcome for reusing complex prompts. Good stuff. Now, let's circle back to the economics because this seems critical. Pricing.
This is probably one of the biggest strategic implications. Sonnet 4.5 is priced exactly the same as the older Sonnet 4.
Okay, which is...
3 per $1 million input tokens and 15 per $1 million output tokens.
And the key comparison is against Opus 4.1, right?
Exactly. Opus 4.1 is 5 times more expensive.
5 times. So if Sonnet 4.5 is now outperforming Opus 4.1 on many complex tasks, as the benchmark suggests,
Then you're getting superior or comparable performance for 1/5 of the cost. That fundamentally changes the calculation for enterprises using these models at scale via API. Sonnet 4.5 becomes the default high-performance, cost-effective choice for a huge range of tasks.
that's a massive shift in the value proposition. Okay, looking ahead now. Anthropic also announced an SDK, the Claude Agent SDK.
Yes, this basically packages up the infrastructure that powers their own Claude Code agent.
So developers can build their own custom agents.
Precisely. The SDK provides the tools for agent orchestration, managing memory with the new memory tool, handling context, tool usage, permissions. It lets developers leverage the Sonnet 4.5 model to build their own sophisticated long-running agents tailored to specific workflows.
So they're not just providing the model, they're providing the scaffolding to build complex applications on top of it.
That's the idea, democratizing the creation of these advanced agentic systems.
And finally, there was this Imagine with Claude thing. What's that about? It sounded a bit more experimental.
It definitely seems like a showcase of future possibilities. From the descriptions, it sounds like an experiment where Claude can generate software, including user interfaces, essentially on the fly.
Generating UIs without pre-written components.
That seems to be the implication. Real-time interactive code and interface generation. Moving towards this idea of disposable software created instantly for a specific need.
How exactly it works under the hood.
Yeah, Anthropic hasn't really detailed the mechanics. What's enabling that real-time generation and execution isn't quite clear yet. It hints at some potentially very interesting, undisclosed techniques they've developed.
Okay, let's try and synthesize this. If you had to pick the 3 most critical technical takeaways about Sonnet 4.5 for developers and architects listening, what would they be?
First, I'd say the 30-hour autonomous operation capability. That jump in agent endurance is a major engineering feat and unlocks new kinds of applications.
Okay, endurance. Second.
Second, the memory tool. Providing explicit persistent storage outside the context window is a fundamental architectural shift for managing state and long-running, complex tasks involving large amounts of information, like code bases.
Right, external memory. And third.
Third has to be the performance-to-cost ratio. Matching or exceeding Opus 4.1 performance at 1/5, the price makes it, by far, the most efficient high-end model Anthropic offers for complex work. It redefines the economic baseline.
Endurance, external memory, and efficiency.
Got it. And what does this mean for the humans, the engineers working with these tools?
Well, it continues the trend, doesn't it? The role keeps shifting upwards. Less time is spent on routine code implementation, which the AI handles increasingly well.
And more time on.
More time on higher level architectural thinking, strategic problem definition, designing the prompts and the agent's goals, supervising the AI, and integrating these powerful tools into larger systems. You're becoming more of an AI orchestrator and less of a line-by-line coder.
A shift towards oversight and design. Okay, let's wrap up with a final thought for our listeners to chew on.
All right. So the success of this whole generation of AI, models like Sonnet 4.5, really hinges on how robust these new context management features, the memory tool, context editing, prove to be in the real world.
Right, if they really work reliably.
If they genuinely allow an agent to effectively process and use information from, say, an entire large code base over a 30-hour period, constantly updating its understanding without catastrophic failure, what comes next?
What's the provocative question? What are the non-obvious infrastructure requirements needed to support hundreds, maybe thousands, of these 30-hour autonomous agents running concurrently within an enterprise? Beyond the SDK tools Anthropic provides, what new kinds of monitoring, orchestration, security, and operational tooling will we need to manage that level of sustained AI activity at scale? Managing fleets of agents running for a day and a half straight is a whole new operational challenge.
Managing long-duration AI fleets at scale, that's definitely something to think about.